Hello everyone, in this video we're going to see the solution to the LeetCode problem, house robber. So in this question it's given that we're a professional robber and we're planning to rob houses along a street. So we want to maximize the amount of money, and the amount of money in each house is given by an array. And we cannot take money from two consecutive or two adjacent houses. So basically the question is translated into we are given with a bunch of values which are stored in an array, and we want to maximize the value taken, but we cannot take value from any two adjacent array elements. So for example, if this is the array, then we can take 3 and we can take 1, so we get 3 plus 1, our answer as 4. Or suppose we take the example as 2, 7, 9, 3, 1. So in here the maximum you can see will be 1 plus 9, 10 plus 2, 12. So we want to maximize the amount of money which we can get. So for this we'll be having a dynamic programming approach. So the idea is that at each point I'll be calculating what is the maximum amount of money I can get till that point. For example, suppose I have 13, 14 and 15. So here the maximum at till this point that I can get is 13. Till this point I can get either this or this, whichever is the maximum. So maximum is 14, so at this point the maximum I can get is 14. Then at this point the maximum I can get is either this plus this minus 2 or its previous. So this plus this minus 2, 28 is greater, so at this point I can get the most as 28. Let's take another example. Suppose I have 13, 100 and 15. So at this point the maximum I can get is 13, at this point 100, and at this point also 100, because instead of taking 15 and 13 I can only take 100 and be on my way, which will give me my maximum value. So at any point I can take current plus current minus 2, where current is the index of the house, or leave current house, or leave current and take current minus 1. The current is meaning the total current house plus current minus 2. So the value of current house plus the maximum till current minus 2 or the maximum till current minus 1. So it will make more sense as I code it out. So as I said, we'll be having a dynamic programming approach, which is going to be very simple. So let's make our array, which we'll call dp. So dp of I will tell me the maximum amount of money I can get from the first I houses. So is equal to new int, and length will be nums dot length. Okay, now we have to consider some cases, such as if there's no house, if nums dot length is 0. So if nums dot length is equal to 0, then return 0, because no house means no money. If nums dot length is 1, meaning that there's only one house, so we can just take the money from that house itself. So nums of 0. If nums dot length is equal to 2, then we have a choice. We can take the first house or the second house. So return math dot max nums of 0 comma nums of 1. So the first three will be our base cases in our array. So dp of 0 will be 0, because if there's only one house we can take the first itself. Now dp of 1 will be math dot max. Let's just copy this. dp of 1 will be the maximum of either the first house or the second house. So this will be dp of 1, and starting from dp of 2 we'll apply our formula, either the previous house or the current house plus current minus 2. So int I is equal to 2, I less than nums dot length I plus plus. So like I said, dp of I will be the maximum of, meaning math dot max, of either the current house, that is nums of I, plus the maximum till current minus 2 or the maximum till current minus 1. And in the end we return, as we want till nums of length, so return dp of nums dot length minus 1. So at each dp of I, we're calculating the maximum amount of money I can get from the first I houses. So if length is 0, no houses, no money. If one house, then we can take the money from that house. If two house, then we have a choice, either the first or the second. So dp of 0 will be the first house, dp of 1 will be either the 0th house or the first house, and starting from the second, I can either take 0th. So if I is equal to 2, I can either take the first house or take the 0th house plus the second house. So let's try to run it. I did dp of 0 is equal to 0, nums of 0. Yeah, okay. Okay, so we got runtime of 0 ms, which is faster than 100% because we did this in O of n using dynamic programming. And this was dp of 0 is equal to nums of 0, meaning the first house, not 0. So that was our approach. Thank you.